Let's talk about one of the most maddening things in design and manufacturing, getting the color on your screen to match the final printed package. It feels like a world of chaos, doesn't it? But there's a way through it all. So today, we're going to show you how to take back control. So, does this look painfully familiar? You spend, weeks getting a design just right. That brand color is absolutely perfect on screen, only for the final box to show up looking, well, just wrong. That bright electric blue you loved is now a sad, dull navy. The glowing orange is just a murky brown. It's super common, and I'm here to tell you it's not your fault.
Yeah, this isn't some random fluke. This whole what you see isn't what you get thing is a universal problem. But here's the good news. There's a really clear reason why it happens. And once you get it, you can totally control it.
Okay, let's just get this out on the table right away. You are not a bad designer, and your printer isn't necessarily doing a bad job. The real root of the problem is, well, it's physics. It's that simple. Screens and printing presses create color in two completely different ways. They are literally two different worlds running on two different sets of rules.
So, let's dig into that. Let's try and bridge that divide. Because if you want to control color, you have to understand why it shifts in the first place. And that all comes down to the big one, RGB versus CMYK.
Right, so your screen, your phone, your monitor, it works in RGB, red, green, and blue. It starts with a totally black screen, and then it adds light to make all the colors you see. The more light it adds, the brighter it gets, all the way to pure white. Print is the total opposite. It uses CMYK ink. That's cyan, magenta, yellow, and black. It starts with bright white paper and it subtracts light. The ink absorbs light, and what's reflected back is the color we see. So, one world is adding light, the other's taking it away.
And that fundamental difference leads us to this really important idea called a color gamut. All it means is the total range of colors a device can possibly create. I love this analogy here. It's like a chef's pantry. Some chefs have a giant pantry filled with every exotic spice you can imagine. Others have a more basic, standard set of ingredients to work with. And here, wow, this chart just says it all, doesn't it? The RGB gamut of your screen is that huge pantry. It can create millions of these vibrant, glowing colors, those electric blues and neon greens. But the CMYK gamut for a printing press, it's a much smaller pantry. The inks just can't physically mix to create those same super bright colors. It's like asking a chef with salt, pepper, and flour to make a dish that requires saffron and truffles. It's just not going to happen.
So this is the million-dollar question, right? If these color worlds are so different, how in the world do professionals manage this? How do they get predictable, consistent color every single time? Well, the answer isn't just hoping for the best. It's a system. You see, pros don't just cross their fingers and hope. They use a really solid system that's built on international standards. This is how they predict and control how a color is going to look, from that very first design concept all the way to the final package coming off the press.
And that whole system really stands on three crucial pillars. First, you've got profiles, which are like color translators. Second is measurement, making sure everyone is seeing and reading color in the exact same way. And third is proofing, which is the final binding contract for what the color should be. Let's break them down. Okay, pillar one, the ICC profile. The easiest way to think about this is like a universal translator for color. It's just a little data file that perfectly describes the color gamut, that chef's pantry, of a specific device, whether it's your screen or a huge printing press. So when you convert a file, these profiles tell the software exactly how to translate the colors from that big RGB world into the smaller CMYK world as intelligently as possible.
But, a profile by itself isn't enough. You need standardized conditions. Think about it. Color is just reflected light. So to agree on a color, we have to agree on the light we're seeing it in. That's the D50 standard. And we also have to agree on how we measure it, especially with modern papers that have optical brighteners in them. That's what the M1 measurement standard is for.
And this is absolutely critical. If you are looking at a printout under the warm lights in your office, and the printer is looking at it under cool fluorescent lights in the press room, you will never agree on the color. Ever. Even with a perfect file. Standardizing how you view and measure color is completely non-negotiable.
So, that brings us to pillar number 3, the contract proof. This is your single source of truth.
It's a super accurate physical printout made using all the right profiles and standards that shows you exactly what the final job is supposed to look like. This little piece of paper becomes the target. It's a legally binding agreement that the printer has to match. But how do you know if that proof is actually accurate? We don't just say, it looks good to me. We use math. This term, delta E 20,000, or just delta, sounds complicated, but it's really just a score. It's a number that measures the distance between two colors, like the target color and the color on your proof. A low score is great. It means they're super close. A high score means you can see a difference. And here's the number you need to know. According to the official ISO standards, for a contract proof to pass, it needs to have an average delta E score of 2.5 or less. That's it. This takes all the opinion and guesswork out of the equation. It's not about what I think or what you think, it's about what the data says. Okay, that was a whole lot of theory, I know. But how do you actually use this stuff on your next project? Let's boil it all down into a super simple 3-step action plan to turn this theory into reality. All right, here's exactly what you need to do. 3 simple things. First, you're going to design and export smart. Second, you're going to demand smart proofs. And third, you're going to define your brand colors using data. Okay, step 1. Keep your original artwork in that big, beautiful RGB space for as long as you can. Then, when you're ready to hand it off, export it as a PDF/X4. That's the modern standard. And here's the most important part. When you export, you have to embed the correct CMYK output intent. That's the ICC profile your printer gave you. That tells everyone in the process what the final target is. Step 2, and this is where you really take charge. Never, ever accept a proof that doesn't have data attached. You need to ask for, no, demand a contract proof that's certified to the ISO standard, and it has to come with that verification report showing the delta E scores. Oh, and make sure you specify that it was all measured under M1 conditions. And finally, step 3. For those really critical brand colors, the ones that are absolutely non-negotiable, you gotta go beyond just a name and number. You need to give your printer the color's digital fingerprint. It's called spectral data, and it comes in a tiny little file called a CXF. This file is literally the DNA of your color. It removes all guesswork and ensures that color is as perfect as technology can possibly make it. So really, it all comes down to this. It's about changing your vocabulary and your expectations. Stop chasing this impossible, subjective idea of an exact match. It doesn't exist. Instead, start demanding a measurable match, a repeatable match, one that's based on cold, hard data and universal standards. And that leaves us with one last question for you to think about. Take an honest look at your own process for handling color. Is your workflow built on hope, on just crossing your fingers and wishing for the best, or is it a professional system built on data, on communication, and on standards? Because the choice and the control is all yours.